All right, so what we're doing here is just a first initial proof of concept demonstration of the Worldwide Electric VFD. This is specifically for Worldwide Electric, and so we've got a Worldwide Electric motor over here, a Worldwide Electric VFD over here, a Rattler 3i over here. Here's a three-phase circuit breaker. We're just temporarily powering this from a last gas power supply, but what this will do is the next step is to make it actually run on the 24-volt output from the VFD, so there'll be no electrical connection apart from the three-phase supply. This is run from here, from the three-phase supply at the IATL here. What we're seeing on glance here is the detailed display of the VFD, including all the Modbus registers that the folks have called for, where you can see the bulk of them are at 0 because the VFD is off right now, but it's set to run at 60 hertz and so forth. So what you can do from glance is you can turn the VFD on. We've got a little display at the top over here. It's now negotiating its way from glance through the cloud, through the secure connection, to be able to turn the VFD on. The motor starts up, the VFD ramps up with the parameters that are set. It's set to 60 hertz or 1800 RPM with a 20-second acceleration ramp, and you can see it's running up to 55, 56, 58, 60 hertz. It's running at the desired speed. What you can do is you can have a look in glance to what the latest values are, and you can see that the output frequency now from the VFD is in fact at 60 hertz. It's drawing 1.1 amps and so forth, and the various voltages and so forth. The motor is not loaded, so it's not showing any power. Plus all the other parameters that come out of the Modbus registers in the VFD. You can change the speed of the VFD, and so for example, if I change it to 40 hertz, I press the button, it shows pending here while it negotiates over the secure connection the change of speed. It gets downloaded into the device, and you see the motor changing speed. It's ramping down with the parameters that are set in the VFD, 44, 43, and so forth. This has got quite a slow ramp to the new speed. You can see that it's refreshed the device 9 seconds ago, that it's commanded to be at 40 hertz, and over here you'll see that the speed is being reported from the device is actually at 39.91. This is faithfully showing what's actually on the VFD, a little bit of a scaling tolerance, and so that's 39.9 hertz, faithfully reported in glance what the VFD is actually doing, and this means that you can actually see the parameters in the VFD remotely from anywhere. If I click on to more details, you can have a look at level 3, some errors, diagnostics, communications, and so forth. And these are all the values that are coming out of the VFD. These are the process values which are scaled. If you uncheck this box over here, these are the raw Modbus values that are coming out of the VFD. So for diagnostics, a person can see exactly what the VFD is doing and when it was doing for diagnostic and support of the customer. And that is how you do remote monitoring and control of a Worldwide Electric VFD and motor from anywhere.